complex, I wouldn't make you solve it. You just have to set it. So that was it. I don't. Did anybody actually solve it out? Did it? What was, I didn't know. What did you guys get? Yeah. What was the answer? So the answer, if you happen to solve that other one out, the more complex one was 20.6 for x. Take that up.
Oh, it's like attention.
All right, so that's the stuff we've done. That's your potential exit tickets. Different number of sides, so you'll have to recalculate something. But
That's the case.
wait, I
have a question.
I'm not going to do anything for the video on that.
Fees or notes on it?
No, are you seriously any notes for those three?
No.
Piece of cake. The exit tickets are always going to be like the easiest thing I can possibly give you, and still feel like I'm actually testing you on something. All right, here's what we need to wrap up, because in this class, I think we missed a lot of stuff. So I got to go kind of quick. It'll be recorded. I'll get to this stuff later.
It's the best method, most. So like whenever.
Yes, I'm not sure when that'll be right now, but just remind me, like say, hey, is this good time? Because I'll forget, guaranteed, no doubt. All right, so we did regular. Oh, here's the other thing. I don't remember if we did this. I did it in some class. I didn't in some class. This is the other type of problem. This is number 9 through 14, and I assigned those the other day, but I don't think we actually got to it. If they give you a question about a regular polygon. So again, this has to be given that it's regular polygon. No other way to know this. But they don't tell you how many sides, and they don't tell you to solve for one angle.
You divide it like this.
They tell you how much one angle is. They say one angle is that big. You have to reverse the process.
Oh.
And I gave you a formula for it that you will work fine if you want to memorize it for my quiz. So for my quiz, the formula was, I had it up there, apparently we may not even done that. I don't remember which classes I got to it, which I didn't. So the formula to solve for the number of sides, again, has to be a regular polygon. Otherwise, we have no idea. If it's not, then the angles could be in there. We said if you just take the number 360 and you divide it by 180, subtract. How can I write this? I have to write it out, I guess. Wait. You'll see it in here.
Please.
Oh, yeah, just copy it down for now, Ava, since you have it. That will give you the number of sides right there. Oh, because you skipped into the storm. Yeah, all right. Well, again, I'll give you this in a minute. I'm going over, this is the lesson part. We'll get the pages in it. This is not the exit. No, you do need to know how to do it for the quiz, but you're going to have practice time like 20 minutes.
The bell where we just did one part.
No, this has nothing. Well, I mean, it's the reverse of the middle bell work. In the middle bell work, we solve for the angle.
Mm-hmm.
Now, though, they're giving us the angle. They're saying it's a regular polygon. So this is the formula. All I did is I took another formula we learned and I reversed it to figure out how to solve for the sides. Here's the problem. You're not going to remember that for the EOC. No way. Right? I shouldn't say that no way, but it's doubtful. You might not even remember it on the quiz. You might get it messed up. So I'm going to show you the better way to do it.
I'm a racer, so I don't want.
I mean, keep it, because for the quiz, you could probably look at it 10 minutes before the quiz, or maybe I give you 10 minutes to look at it real quick. Remember the chart. Chart works for everything. If I create a chart and I say, all right, if it has this many sides, and we know a triangle is 180, we pretty much know 4 sides means 360, and then we're just adding 180. Like all you're doing is you're sitting there. You don't have to use the formula every time. Just keep adding 180. Every time you add a side, you're adding 180. So in your calculator, just add 180, add 180, add 180. And then this number just comes from the total divided by the sides. That's all I did. 180 divided by 3 is 60. 360 divided by 4 is 90. 540 divided by 5 is 108. This is how many degrees in one angle of a regular polygon. They all have to be the same, right? So if I add these 5 up, that would equal 540. They have to be the same number. That's why we can solve for it. If we didn't know it was a regular polygon, we can't figure out one angle unless we have more information. So if you kept doing this chart, you notice they're getting bigger as we go down. One individual angle getting bigger as we go down. Eventually, you're going to hit 144, and you just look at how many sides you got. Oh, yeah, 144. Ooh. Oops. Okay, it does come up. Yeah. Oh, that was mine. Yeah. So even if it was a really high number, you could do that. I mean, like, and it wouldn't even take you that long. You're just saying plus 180, plus 180, plus 180, and then come back and say this divided by that, this divided by that. I mean, in 2 minutes, you could probably go all the way out to 20 or 30. And I don't even think you'll ever have to worry about a number higher than that, especially not for a problem where they give you this and you're figuring that out. They're never going to give you a really big measure of one angle. But you'd also have all the total degrees for all the other problems. So you wouldn't even have to do those. You could just look at your chart and say, okay, well, it's got 7 sides. That means it's going to have 900 total. Or they might give you a problem that says, what is the total interior degrees if it has 37 sides? I don't know, whatever you need. If you get a problem and you need more, then continue the chart out later. So just I do it for a minute or two, however far you can get in a minute, and then start doing the test. And then if you need to extend it later, you can.
What's the right column?
The far right is one angle of a regular polygon. It's got to be regular. That's because that's the only way you can solve, because in a regular polygon, they're all the same number. That's what allows you to solve. Like what we did for the bell with the middle.
How do you
This.
know the far right side? How do you call it?
Oh, it's this divided by that, because this is the total. Because remember what we did for bell work? We said it's like x plus x plus x plus x plus x, because they were all the same measure. And then we said that has to equal 540. So just like this line right here. So
Okay.
that means it was 5x equals 540, so we divided by 5. All right, so that's what I would do for those. You can memorize the formula if you want to for my quiz. Just know that in the at EOC, you're probably not going to remember that formula. No, I want you to create it on your own at some point. So I'm gonna probably give you a little time before the quiz on Tuesday. That might be a good thing. Now you got to recreate it on the quiz. I need to see it. You can't like have a piece of paper that you then just use and just write an answer. Just recreate the same thing they're going to do right. Yeah, I don't want people just copying it. I want you to at least go through the process. I'm going to let you use it as proof of showing your work. I want you to create it, not just have a picture that you try to memorize yourself. Then trust me, you're not the first person. Let's see. Oh, so there's that section that we've already gone over 1 through 4. Okay, so we need to do external angles. I don't remember if we got that in here or not. Just this right here. Okay, so I'm just going to review it. It'll be recorded. We need to get moving because we're doing part of the next lesson, 7.2 today also, which will be on the big quiz. We said, or they said, or this theorem says, if you have, actually, I don't need those. If you have a polygon, a lot of times you just have, a polygon drawn just with only interior angles. Like that. But sometimes you'll see these extended sides out. That creates an exterior angle. An outside angle, right? Exterior is outside. None of those angles, 1, 2, 3, 4, 5, 6, none of those are inside that polygon. That's what makes them exterior. So that's the polygon. If I trace that, No angles are, I mean, there are angles in there, but they're not numbering the angles inside. So those are all exterior.
All of them?
Yeah, they're all outside, right? But none of those are inside. That's the definition of interior and exterior. Anytime you have exterior angles, and one of your hints is going to be that the sides are extended. If they don't extend any sides, like here, probably not going to be about exterior. Anytime you're seeing this stuff outside and all these little angles, and it looks like a spinning wheel or something, that's your clue. Okay, I need to remember that those all add up to 360.
Exterior equals.
Always, it's not like the interior where it depends on the number of sides. A triangle, a rectangle, any quadrilateral, any four-sided, pentagon, hexagon, all of those. Doesn't matter how it could be. Have 100 sides. You can even really draw. The exterior angles add up to 360 degrees. One way to just have that down is memorize. I'm going to really quickly show you a way you could, if you, again, mostly for the EOC, if you forget that, there's a way you can kind of back into it, like figure it out. If you know, I know they always have the same number. Is it 180? Is it 360? Is it 540? Is it 90? Like, I don't remember.
What is this?
So we have this drawn, right? So I've drawn, and we know a triangle pretty well. So start with a triangle. And they're saying, what do these add up to? Angle 1, angle 2, and angle 3. What do those add up to? Or they're telling you to solve. Well, let's say you forget that. Let's say now it's the EOC time. It's been a long time. You forget. Well, I know they had the same number. How in the world? What do we know about the number of angles in a triangle? I'm sorry, the interior. What do we know about the interior angles of a triangle? They add up to 180, right?
Yeah.
So 3 angles. I always erase that. I keep meaning to freeze it. I keep forgetting. I know the interior angles add up to 180, right? And there's a different version of this. I'm giving you a longer version, probably, or maybe not. So here's the little bit trickier part. What's true about all of these little sections?
They got to add up to 180.
They do, right? They're all we did is we took a line and we split it into 2 angles. So all of those little semicircles, we've done that before. That's what
90.
They're all 180, right? So, wouldn't be 90 because that's not straight up and down thing. But what's true about, and isn't every one of those semicircles, isn't it made up of one interior and one exterior? Like every one, right? Interior, actually here. This. That's my favorite color on the board. Just so you know. So that, I said that green's my favorite color. Out of all the colors in the Scotland. Just so you know, Logan. I wanted to show. Oh, I got to use this though now for the yellow. So there, color coordinated for you. The yellow is interior, the green is exterior. So every one of those 180s is made up of an interior and exterior. What's true about how many different 180, how many semicircles do I have? So what's the total of all those semicircles? I have 3 of them. Yeah, if each one of them is 180, right? I multiply that by 3, I got 540. So if the 180 is all the yellow, right? All the yellows add up to 180 because that's what the interior of a triangle add up to. What am I, and all the only thing I have left is the green. What do the green have to add up to? If this is the total of everything, that's interior. What's left? I just subtract it out, and I just say 540 subtract 180. So that's what the green have to add up to. I'll tell you another thing you could do. Just pick a specific triangle. Pick an equilateral triangle where you know all the angles are 60. If all the interior angles are 60, what is every exterior angle? Yeah, because they have to add up to 180, right? Well, what's 120 plus 120 plus 120? 360. So you could pick a specific shape also, because if it works for one, it's got to work for all of them when it comes to this stuff. So that's another way to do it. Really quickly, let's do a rectangle. How many sides to a rectangle? So, well, I should have said how many angles, but that's it. So if I have those angles are made up of an interior and an exterior, right? Just like the triangle was. I just have one more of them now. Every one of those, again, is going to be made up of an exterior and an interior. Yellow. So how many degrees between all the semicircles? How many total degrees? Well, each one is 180. So 180, 180, 180, 180. So how many total? So we're just multiplying times 4, basically, right? So again, 4 angles, 720 between all the semicircles. How many in the interior? Yellow. Yeah, we've done a 4-sided figure before, right? 4-sided figures are always going to have 360 in the interior. Or think of a square, a rectangle, 90, 90, 90, and 90. That'd be 360, right? So what's left over for the green, the exterior? Didn't change, right? Change between a triangle and a square, rectangle, whatever. So you could go through and figure it out a few different ways on your own, what the exterior half that up to. Like I said, you can always just pick a shape that's a regular triangle. A regular triangle would be an equilateral triangle, remember? Equilateral triangle means all the sides, all the angles are the same. You could pick a square, a regular rectangle. Really, it actually works for any rectangle. You could pick for a pentagon, you could pick a regular pentagon. And you could solve for a regular pentagon. We just did it a minute ago. What was every angle of a regular pentagon? That's the one we did for bell work. Set the middle problem. What did we get? We got 108, right? So for a regular pentagon, the interior angles were all 108. So what's every exterior angle? If an interior angle is 108, say it. That's the interior. So what's the exterior? Oh. So again, if this is not regular, but let's say it was, if that's 108, what's that? Yeah, we subtract it from 180, right? You're always going to be subtracting it from 80 because they're always going to be making up a line. So what would 72 times 5 be? Because I have 5 of those. Right? So again, it will always be 360. So there are other ways to back into it. So don't just guess, is what I'm saying. Like you can back into it pretty quickly and figure out what it has to be. Because some of you will just guess. I know you will. Don't. Take the shape. You use whatever shape you want, because really once you use one shape, every shape's got to be the same. And then you'll always get 360 is the number you need to use. So if you forget that formula or if you forget that number, you can back into it. We've already done those. We've done those. So what do you need to do on these? These are the other ones I assigned. What is that about? I speak Spanish. Who am I going to call on? I'm going to call Sora. I never call on Sora. Sora, what are those about? Well, just look at it. Tell me something. They're giving us a bunch of variables and numbers. What are those about? Specifically, just anything. What do you kind of weren't in here for this piece, but I'm still going to keep asking. What are those expressions about? What are all these things about? Well, first of all, and again, you weren't here when we really emphasize this. If we see a degree symbol, if you see that circle, the degrees, it's got to be about angle. Like there's no questioning what it's about. If they don't see that, then it's probably about the length. It should be about the length of a line. That's the easy way to tell if it's about the length of a line versus the degrees. That symbol. Now, sometimes the book's pretty good about always putting the degrees. but some worksheets, sometimes they won't, they'll forget the degree. Occasionally I could forget it on the quiz, just forget to put the degree mark and try not to, but you can always ask and say, hey, is this supposed to have a degree symbol? And I'll tell you, yes, oh yeah, that should, and then I'll tell everybody. But if you don't see that degree symbol, it's got to be about the length of something. So now you already said those are also all outside, right? So if we know all of those are outside, what's true about them? Have to add up to 360. Doesn't matter how many of them. It's not like interior where you got to like kind of figure some stuff out. If it's only exterior angles, they have to add up to 360. So in every single problem, you're doing the same thing. Those are all exterior. Those are all exterior. I'm not going to go through. I think you can figure. Oh, just be careful on 18 because there's kind of those two right next, actually three right next to each other. There you go. Yeah. Just make sure you set them all equal to 360 and then solve them. So I'm not going to really spend a lot of time.
That's all you did?
Yeah, they have to add up 360, right? That's it. But the key is remembering what number when we haven't done this for 2 months or 3 months and you're at the EOC, you're gonna maybe not remember exactly what that number is. That's when you have to think about it. Don't just guess. Try to figure out, well, what if I had a shape? What would the external angles have to add up to? And do a couple different shapes, and you'll see it's always the same number, and then you should be good. Last thing, which I'm not going to do a whole lot on either, if they tell you we didn't really do names, how many sides does the pentagon have?
Oh,
Not 8. That would be octopus, right? So pentagon has 5. If you don't know that the word or the abbreviation PEN, PN typically means 5, like there's literally a building that's a government building called the Pentagon that has 5. It looked like pentagons. In 9/11, yeah, long time. It was one of the buildings that got hit. Yeah, the 2 towers got hit. Pentagon. Oh yeah, of course they fixed it. Probably for like several $billions or something crazy. So that one just tells you it's got 15 sides. What would 23 be if you had to guess how many sides 23 behind? So what would you say number of sides that is? No, you can't 0 sides. Number 23. N is not like you got to just kind of think, well, that's going to like 9. This is not on my quiz. Not even my
I was going to fail.
What about triangle or going?
Yeah, that's the one I know.
There we go. Good job. What about hexagons?
That's the only one that I know.
6. Yeah. So the only thing you would need to do now is how do I solve and know what the exterior angle is for each of those regular polygons? There. And the only way you can even do this is because of that word right there. Otherwise, you can't do it.
It's a regular.
Yeah, you know.
Equal.
So they all have to add up to 360. And if we know how, and again, the number of sides is the same as the number of angles. So if we know it's got 6 angles, and we know those angles have to add up to 360, that's how much one extra one.
Right, sorry.
Yeah, now it's probably a pretty good time. I'm going to do the new lesson, but that's not going to be on the, but actually it will be on the quiz, so hurry about it. But there'll be an intro to it. Here, just take that. All right, so here, we're moving to the next lesson. So turn to, I think somebody said it was 13. Oh yeah, if you haven't ripped out pages, come on up. Oh, here we are. If you have the pages, turn to page, I think it's 13, just at the beginning of the next lesson. So somebody let us know if that's right. Anybody else? 5, I'll write it up in a minute. 5 through 58 for you guys if you're hearing.
But
Evan, you're here?
like if you like
No one's here. 5 through 58. As soon as I get to the next lesson, I'll see. Oh yeah, it is page 13. Hold that thought. There. So tear out that, and we're on page 13. Oh yeah, he didn't.
Does he have to get up?
Vizier, did you turn pages up? So why haven't you got none yet? Everybody else is up and got the book. Chatting away, aren't you, dear? Oh, actually, what else? I don't think he's on my list. I can't believe you guys didn't remind me to record.
I thought you were here.
Totally forgot.
5.
Yeah.
Way too big.
That's not as funny. Yes.
Mr. Gill, do you have a Band-Aid?
I do.
Name of two. Play forward.
You guys is passing. Oh, wait.
Ah, do you have cute Band-Aids? That's later.
No, that's
Yeah, 34 minutes.
Oh my goodness.
All right. You didn't want to get
Takes on the case.
Perfect. What?
Let's see. I gave him this somebody. No, that's somebody in fifth left it. I gave them the box yesterday. Maybe they didn't see.
No, it's not. Oh my goodness.
So you're not going to Band-Aid at all then?
No.
I don't have any cute Band-Aids because we don't need the Band-Aid.
I mean, you know how to like do this for me, really, like.
Oh!
Oh my god.
Bro, look how wonderful this paper is, though.
Thought that was a miraculous.
Yeah, you like.
Whatever they call it.
No.
I could have something better. It's usually like.
Okay, well. Not this, and whatever you said. That's one more thing. No.
Yeah.
All right, so we need to move forward. Oh, once you're done tearing, they go over there. I want to see close up. I want you to have a little practice time before the I want you to have a little practice time before the quiz. I need you going.
What is that?
Guys.
I think. All right, so I'm gonna do my own version of what the book does. I'm gonna if you really want to, this is on the quiz next week, Tuesday. If you want to, you can memorize these things. I'm gonna try to explain it to you though, so that hopefully it just seems intuitive. And it'll trust me, it'll seem complex, but then I'll say, here's what you need to understand. So we are moving on to a topic, as you see, that is called parallelogram. Parallelogram. What does it say a parallelogram is? So you can read it from page 13. What's it say? Very first thing it says is what? So again, a parallelogram is a quadrilateral, only a quadrilateral. So it only has 4. There are other figures where all the opposite sides are parallel, but that doesn't make it a parallelogram. So if you see that if the word problem, there's no picture, and it says a parallelogram, it has 4 sides by definition. There's no other type. Period. Yes. So now here are the traits that they have. What's the first trait based on the name? Well, no, that's the definition. What the name? What do you think's involved if the name is a parallelogram, right? So, and this is drawn maybe differently in your book. I don't know. So those sides are parallel. Top and bottom are parallel. The left and the right are parallel. Tell me another type of parallelogram. Yeah, rectangle. Square, right? Those are also parallelograms. They just always have 90-degree angles. These obviously are not 90 degrees. So now here's where it's going to get a little confusing. So just take a deep breath, try to follow along, and I'll give you the summary. In a parallelogram, if we know we have parallel lines, what else do we do with parallel lines? Remember a lesson where we use parallel lines? Do think about them a lot. I think about them often. So, what lesson did we do something? We said, if you have two parallel lines, and then we did something. We did that. So we learned when you have a figure like that, which is really what we have here. If I extended that out, and if I extended that out, I would, oh, actually there is a way to do it. Yeah. That's really the same figure. Two parallel lines with a transversal going through them. It's just that we don't have all the extra space outside. Like we don't have that one going on and that one going on, and we don't have the left edge. So it's like we just kind of erased. It's like we kind of just erased a bunch of this stuff, and we just had this little section right there. But it's really the same thing. It's the same exact concept. So what was the important thing we said in this? When we had that figure. And we figured a bunch of angles out there. We solved for angles. There were only two different options, right? Again, here's where you need to start tuning in. So if I just see heads down, I'm assuming you're looking at phones, or I'm going to start banning watches. That's the latest thing, right? Right? Jacob would never be doing that. None of you would ever do that, right?
Yeah.
I know everybody is doing it. Trust me, I got classes where I got 3 or 4 in every class. And it used to be like 1 all day. Now it's like 2, 3, 4 in every class that are on their watch nonstop. I'll make you take the watch off.
Yeah,
So
Josh.
pay attention. All right, so what we said in this figure is if I knew this angle, let's say that's 60. What's the angle right next to it? They have to add up to 180, right? Remember, that's a line. That is a semicircle situation. So if that's 60, I know that has to be 120. But didn't we also learn about vertical angles across from each other? What's true about vertical angles that are across from each other? Evan. Like what's true about the angle across from that 60? Yeah, 60. Right? We said that's got, and plus we also have another semicircle if I wanted to think of it that way. I know that's 120. I know this is a semicircle. So 120 means that has to be 60 anyway, if I think about the semicircle. And then we learned a whole bunch of other stuff. We learned about, if you remember, corresponding angles, like angles that are on the same side, but not next to each other, had to be congruent. That was corresponding angles. Well, now we're back to saying, okay, well, wait a minute. If I know this is 60, that's got to be 120 because they have to add up to 180. Well, across from that has to be 60 and then 120. So we said, well, wait a minute. There's only 2 different numbers. Like, we just solved out for every single angle, and there were only 2 different numbers in all 8 of those different angles. The same thing here. Because it's really the same as this. We just have different sets. So I'll kind of show you. Here, we have parallel lines cut by a transversal right there. Over here, we have parallel lines, if I continue that one out, cut by a transversal. Over here, which ones did I just highlight? Those, oh, so here we have parallel lines cut by a transversal. And then same thing on the bottom. We have parallel lines cut by a transversal. It is the exact same, that's why we learn stuff in order. It is the exact same concept. It's just more complex drawing. I mean, not really a drawing, it's a shape itself, it's a polygon. So we're going to see the same stuff happen. So based on all those rules, what happens is this angle outside, if we continue it out, is congruent to that. This angle inside is congruent to that. Well, knowing what we know about the corresponding, well, that's horrible. About corresponding angles, if these lines are parallel here, if they are, corresponding angle says this angle is congruent to that angle. This angle is congruent to that angle. That was the corresponding angles part. Now, though, we can go back to the other stuff, alternate interior and alternate exterior. Oh, I didn't mean to put 2 there. Tells us that has to be true. And now if we look at the interior of the figure, the opposite angles are congruent. So again, now we're getting into the actual theorems that you can just also memorize or memorize them. But if you understand this, then you don't have to memorize stuff. Memorizing doesn't last. Opposite angles are the same. Opposite angles here are the same. How can I? Oh, I'll circle it. Those opposite angles are the same. And what's true if they're not the same? What's true about the angles if they're not the same in this figure? Look at 2 angles that are not the same next to each other. Maybe. Well, angles can't be parallel lines. What's true about the 2 angles that are not the same right next to each other? Somebody just said it. Those 2 angles are not the same, right? So what's true about them? Yeah, it's just like the other thing we did. They have if you have 2 angles that are not congruent, then they add up to 180. So for example, these 2 angles add up to 180. These 2 angles add up to 180. So all of those theorems come from really one concept, parallel lines and a transversal. So now we'll just kind of go over the theorem. So look at page 13. Oh, you're tearing out 5 through 58, by the way. I told you pages. So in the theorem it said, or the first, I don't know what order they're in. You can look at the order. It says opposite angles of a parallelogram are congruent. Again, you can just memorize it, or if you kind of remember, oh, well, it's just because of the whole parallel lines thing, whatever works for you. Understanding things conceptually, it lasts longer. If they are not opposite angles, if they're angles that are next to each other or on the same side or whatever you want to call it. Oh, these are also 180, by the way. Because they're not congruent, right? This one is 2 congruent marks, that's 1, so they're not congruent. Well, then those are also 180, and then these 2 are also 180 there. Either they are congruent or they add up to 180. That's the only 2 options in this figure also, a parallelogram. I know it got confusing, but so for the theorem where it says, let's read the one that says, I don't know which one it is, how it's the one that says if they're not congruent, basically they add up to 180. Let's say it, if they call them just look for the one that says they add up to 180. Which theorem says that? Huh? Well, they say it says they're supplementary or something. I mean to add up to 180.
Yeah.
So they call them consecutive. I was trying to come up with a word. I didn't remember what the word was. So consecutive, and does it say they're supplementary there?
Yes.
So you need to write in what supplementary means if you didn't know what that meant. Supplementary means they add up to 180. If I said they add up to 180, you're like, oh, it doesn't say that, did you? Well, yeah, it does. It doesn't say the number. So if they are not congruent, then they have to add up to 180. There's only 2 options. They're either the same measure or added together they equal 180. No other options. What's the next theorem? I don't remember the other 2 theorems. Oh yeah, okay, so that's totally well. Here, I'm gonna go ahead and explain why the really the rest of the theorems work. I'm just gonna do it all in one quick. If we did a whole bunch of different things, if I draw in a line like that, right, or two lines, I still have two parallel lines. These lines are still parallel, which means I have a bunch of angles that are congruent again. That's congruent to that. So that's alternate interior. That's congruent to that. That's also alternate interior. I can say same thing over here. Now that I have the other transversal, that's congruent to that. That's congruent to that. Again, this is just two lines on the top and the bottom, cut by a transversal. Same exact concept we just did a minute ago. What's true about these two? Yeah, that's the vertical angle stuff, right? So again, those are congruent. Now what I can say is, I'm just gonna jump straight to it. I should technically explain one more thing, but I'm not gonna worry about it. If I know that those angles are congruent and they tell us that the sides, we just said the sides have to be congruent, right? I can't do that. Never mind. I'll do that. That's the one we're explaining. Let's see. What piece can I may have to go backwards. I'm not going to worry about going through the full kind of like mini proof. Here's what it all boils down to, though. Remember how we proved triangles were congruent? If we could come up with like side angle side, that stuff, that's what winds up happening in this figure. Because you can basically prove all these angles are congruent all over the place, a bunch of the angles, and it winds up being that we share. Here, oh wait, I can do it this one. This might work. I didn't want to have to erase everything, but if this works, then I can try. Oh wait, I don't know if this is gonna work or not. We'll see. We'll try. Yeah, perfect. So now if I just draw one line in. So again, I know that these opposite ones are congruent. I did that. I knew these are congruent. Don't they share that side right there? Like, isn't that part of these two triangles? Right? So what that means is I can say I have angle, side, angle. I have angle, angle, side, depending on which two angles you want to use. So that means these triangles are congruent. This triangle is congruent to this, and that's how we are able to prove that that side is congruent to that side, and that side's congruent to that, because they're congruent triangles. So if they're congruent triangles, then those sides have to also be congruent. So anyway, it all boils down to the fact, like all of the theorems boils down to the fact that you really just wind up having a bunch of congruent triangles because you can prove so many angles are congruent. And again, that comes from the fact that you have two parallel lines divided by a transversal. And I think that is all we did on the new. Yeah. So here's what you're going to do. Yes, this is your practice time. If you want to practice and redo the bell works, because you're going to do in 10 minutes, you're going to do the exit ticket. So if you want to practice those, you can do those. If you're like, I got those down, I'm good, then you can practice these problems here. Yeah, that's what I'm putting up. You're talking about the big quiz?
No.
Oh, the today, you're talking about the exit ticket today? That's the bell work is all. I don't really have. I'm going to put the bell work back up. If you haven't written that down, write that down. That was your lesson from the 7-1 lesson. Then the purple. Page 9, page 10, page 11. Yeah, all those. That's this is for your big quiz on Tuesday. That's it. The exit ticket, I'm just going to put the bell work back up in a second. Yeah, well, I mean, I forgot to sharpen that ditch. I'm gonna put a string to it so I can hang it over the projector. Because that might be the only way. It is. I don't know who gave me that. Somebody just left it in there. They actually, I think, put it up there. I found it, or they put it somewhere, and I found it, and I don't know if I put it in a different place or if that's what they did. I have no idea who left it. I have no idea. I don't know if it's even you're not supposed to say that out there anyway. Oh, you're not leaving. All right, so you're going, you said?
Yeah. Okay.
Hello. Your name is so appropriate.
My name is so perfect. I know.
Appropriate.
Sorry. Yeah.
Yeah.
All right, hurry back though.
Isaiah, are you okay?
It's all relative. Have you written that down? Have you all written down the assignment? Like that's for the big quiz. I'm about to put the bell work back up so you can, if you want to practice again for the exit ticket today, real quick. I'll just put the bell work over again, and you can try to do it without any of your notes. Since you won't have notes on the exit, I'll be on. Everybody's got this, right? All right. Oh no, actually, it's forward. I think. Marta. There. All right. So there, if you want to try doing those again, try doing those again.
Really? Didn't care, but okay.
Do that a different way. I hear a lot of talk about types of polygons. I hope you're practicing the exit tickets. All right. It would be a shame to miss out on any easy point. No, you can't have an exit yet. Then practice the other column for the quiz.
Are you subconsciously answered, or you answered just to answer?
No, I just
I slept.
like
People make
like what if you like
Cross adults.
Yeah.
They're around, don't you?
I love this. I wore my vitamin shirt yesterday. I got one for free. You should have come by and said, hi, and you would see it.
Well, I mean, yeah, like, confident. He's like, oh yeah, yeah, I get around.
But I need
Yeah.
You're out where?
Yeah.
Oh, they sound crazy. You were out in the street. I'm like, what are you doing out in the street?
Yeah. But you saw.
Oh, I wonder who that is.
Doing it at the same time.
I'm totally on a different train of thought.
Yes.
And you have to know.
Nadia transferred out like 2 months ago.
I knew you had her.
She was initially. Yes, that's what happened. Well, I mean, we're about to take the exit tickets. You hurry back. Oh,
How'd
rejected.
you do that?
Rejected.
Right.
Oh, I didn't know that.
Wait, oh. Yeah, what's your name? Stop viewing, bro.
Oh, it's try. Okay. I learned your name today.
What?
Yeah. If it's interior, yeah. Exterior, no. We said the exterior always adds up to 360, but the interior angle, the inside the shape, yes, that absolutely. Because, I mean, always just go back to a triangle and a rectangle. You know how many degrees are in a triangle. Any triangle.
Okay. Yeah, support.
So what do you mean?
No.
How many are in a rectangle? 60, right? So obviously it's different. But you can then figure out the external and you'll see, oh, well, the external is the same. It's always
I'm getting there
Because
eventually.
if I know an equilateral triangle, they're all 60, right? So what are all the externals? And a lobe, then that up to 180, right? So make a line. 120. 120, 120, 120 is 360.
Oh my God.
Well, for a rectangle, all the integers.
You mean?
So what's the external?
Mine are too.
Yes.
You can kind of back your way into it if you forget some of the numbers, so don't give up, because you're pretty good at figuring stuff out. You just need a trigger to let you know where to start.
At least I don't have time to be
If that goes past like 7 minutes, let me know. If I forget to start the quiz.
Choose my only like outside interior.
Yeah, the new power.
Exterior equals 360.
They just need to start doing this to go. I'm telling you.
Interior is 180.
I'm so let's finish on class.
What did you just say? About interior.
Only 180.
Good, because it was wrong. But you think back through it again.
Exactly. Interior is 360.
Well, interior changes depending on, because think about it. Triangle, what are the, we just know what the interior is for a triangle, but what is it for a rectangle? So that should tell you the interior has to change, which is not the same for a triangle. The interior is the one that changes. Now, though, you could figure out, I don't have time to do it. Think about an equilateral triangle. What are the exterior angles for an equilateral? We know all the interior are 60. You can only sort of all the exterior.
That's Brian.
No, you keep saying that. Quickly.
60, 60.
So what are the exterior? If I drew a line out, what are the exterior have to be?
Yeah, the equilateral 360.
Well, but what are they individually? Like 60 plus what? So they have, because this has to equal 180, right? So if all three of those are 120 and we have three of them, that's 360, right? That's why the exterior add up. So was right. So. All right, go ahead, put your stuff up. I'll pass the quiz out as quickly as I possibly can so you can get started. As soon as you get your stuff put up, I'll hand you a
Can I
quiz.
get mine? Can I get mine? I'm not gonna have to go. I got this. Watch.
You just make a big
Watch. I'm a professional.
They're important.
Watch. No, I didn't.
I didn't know you're talking about.
What? You did.
You're just not a professional.
Sure.
What?
Like every interview
I'm trying to stop him from doing it.
He's a really big line.
If the man wants to do it, he can do it.
like one number.
Or he's just always asking.
Why are you doing that?
Oh.
Exactly. Are you-
Step in. I need to tell you something that you need to know, and I will not repeat it. On the quiz, if I made a mistake and I put X in the wrong spot in one of them, it doesn't affect anything. Just don't go by where like one angle says it's a really big angle and it's not visual. Just ignore it. It was just supposed to be a different place. Just do the math. Just do
Don't
what
give
you
me that one.
It doesn't affect what you do. The process is the exact same.
And can't you?
No, I bet him $20 that he couldn't view it to the end of class from the start. Please stop.
Oh, I see where that's coming from now. I got you.
Hey,
I'm not mad. I'm not gonna lose money. Watch. I will not lose money.
Okay, now I want it, but I'm not paying money.
5 minutes.
I don't wanna. I mean,
Wow.
one money.
You wanna bet on it? Bet.
Nobody made the bets.
I'm saying against me.
I'm not gonna be.
Yeah, just do it on this. No, I don't want you to attach any more paper to the street. Well, then you're running. Well,
Yeah, we just got you there, my deal.
I didn't even hear what she said.
then. Actually, here, I should have done this thing. That one.
Yeah. All right.
Science.
I want to change. Okay, just check.
But I haven't referred to me. Okay. Welcome. Whoa. So, well, there you are, guys. Oh, even though it took a while to get in, some of you, it's plenty of time. Yeah, it's like a minute. Now you kind of know what I'm talking about, the where meaning, like by saying the egg is better help. If you got done, you go ahead and raise your hand. Make sure your name, first name and last name are on there. Thank you. Thank you. Thank you.
It's 17 right here.
I get yours. Yours. And yours already.
Yeah.
Knew you were gonna do this.
Let me just start with this next.
Yes, I specifically did it.
Better.
Please.
I got those.
Oh, seriously. The bomb, it was all in the fight. That's the.
You let it grow out over breaking.
Really big.
I know. I cut it, but I really did. I'm touching for probably a week and a half. I basically
Really? So you.
It doesn't grow in France.
Have you had hair before? Yes.
Oh, yes.
I have pictures. I've shown pictures with you.
I can't. It's hard. I can't.
Sounds nice.
I guess I'll allow phones. See how these go. We didn't all get on 100. Phones will go away. Oh, that's a good idea.
Y'all gotta get on?
Everybody gets a 100. Phone and someone get a 100.
On that,
Everybody?
we're gonna fit. We're not gonna get it wrong.
Well, it doesn't. I'm sorry. 100 doesn't have to be.
Get up now. Get up now.
It has to be an A or a B. What I would consider to be an A or a B. Looks like some people are going to prevent you from having phones, though. Some people are struggling. I would excuse somebody that wasn't here like a couple of days. One day is not enough. You did have to be able to. Although technically that's why I recorded. Why are you guys all moved over and never seen me?
Oh,
Yeah. That's actually. Happy wife, happy. I could say. Maybe.
I wouldn't know better.
All right.
Or,
Have you ever had?
2 seconds.
married? No. There was one we didn't actually get engaged. But the one that we were like out shopping because
Yes, that was
walking on there.
Yeah, what
I
was
knew
that?
she was crazy. Trying to deal with it, and then eventually I'm like, yeah.
Are you saying that you said feet?
Actually, really, what me that said I could have. But I was doing it.
Right here.
Just keep it loose.
So you had a little delusional freak. What do you do? Or were you?
Spanish.
Yeah, she had issues.
Oh.
When was your last girlfriend?
Oh.
When was your last
And the
girlfriend?
class, and the class added
What do you define as growth?
another 3 minutes.
Like last girl you like? Yeah, last girl you.
I don't consider like, I guess like.
Yeah.
Summer I was seeing a girl.
Are you?
Wait, no, okay, so. On that. I don't remember. I think it was. Yeah. Oh, yeah. I'm sorry. Yeah. We're already in the second semester. Yeah, that was definitely past summer. And it was only right at about 2 months. So that's horrifying whether or not we were.
Motion.
What's the longest relationship? And you?
Whoa.
That's too
I'm 6. I already so low.
You'll be there for 2 years.
No, some
No,
people.
that was the one where we were talking about. We had broken up.
10 years. Y'all did they?
For a year. For a long time.
That's 5 years.
Yes, after the first 5 years.
I mean, yeah, it wasn't 6, and I think it was still 6 total.
So you was from
So
5 years.
like
When Mary-
7 was the span, but we were together. I think that was 7.
Yeah.
She's crazy.
Stop.
I'm sure she said, she wouldn't say I'm crazy. She would just say that I'm
I saw the
That-
video.
you gotta share money.
I know, right? I know, it's gotta be, I'm in pretty good shape the way I am. I'm pretty comfortable in life, so I'm not looking for a lot of drama in life. Not looking for a lot of drama. So if I'm real drama, then it's probably not gonna. That's the one that I had the steps in.
No, but not steps. You're so old kid.
Oh,
You're right.
Why not?
And I couldn't do baby years.
You couldn't do baby?
I couldn't handle from about 0 to like 3 or 4. I can't do those years.
Hey,
Why you always
I
saying
could
that?
have anything.
you basically said you wanted to get the new.
I love
Yeah, like I had a girl that wanted kids and we were together and that was what kind of ended it. And she's like, well, I'll take care of everything. No, I'm not gonna be that daddy.
You have to make one. We'll go get the
Stop making out, please.
Oh my God, they're making out again.
They are.
You got it.
I can't stand up.
Get it. Get it.
What the Edward?
What you said. No, whatever.
Regarding the ball. Because I know you're gonna go for the ball. You're looking at you. You're trying to sneak. You're like, how do I get around Mr. Gill to get that ball?
Right.
Why?
Because they gave me, remember I told you it was going to test my schedule so I can take algebra again because I needed to pass a semester to graduate.
Right.
And I hated it.
Oh, but you're in it though. Like you're getting the credit, right?
Yes, but I was supposed to take algebra 2 online, but it was too hard, so I dropped it. So they put
Number 2 can be tricky.
Yeah, and so they put it on my schedule.
Did you not have a full credit for algebra?
No, I only got half a credit. I think
They
I got,
never ever put you in credit recovery for that?
no, and
Or you were supposed to do it and you
no, they never put me in it. They told me I could do algebra 2 or they'll put me in this class. But then I took algebra 2 on Penella's virtual and it was hard, so they just put it in this class.
algebra 2. Well, think about it. I mean, it's perhaps algebra.
Yeah.
What is it hard?
You know why they did that? They literally gave me option, and I was like, okay, I would just try to do it, and it was like so hard. And I tried.
So now you're in algebra again?
Yes, but it's not really the problem. Like the work is really easy, so that's not bad. But it's the kids, like they're throwing stuff. It's like I don't.
Who do you have?
Miss Heiser, and like they just be throwing and.
Wait, who? You're in 1A.
Yeah, I needed.
Oh wow! I was gonna say you had to have gotten your algebra credit by now. So if that is even though it's like before, yeah, that's all.
Yeah, and I was.
Almost all.
They could have gave me the They could have put me into the preparatory, but she teaches God too.
I don't know.
Because they have
Yeah, that's pretty close. But you need, I need to bring you in to talk to my future kids next year and senior year. When I had that conversation with them, like the younger one, about not getting behind and after your senior year, and he's like, yeah, you don't know what you're talking about. Listen to him. You move around, you're in a class that you don't want to be in senior year. When you, so you just got out there?
Yeah.
Yeah, it'll be super easy. It'll be easy today, but yeah, sure. Trust me, I taught it for 3 years. I know that. It's not. That's all you do. It wasn't going to be the old one. But there is something else you might want. Yes. There you go. Yeah, that's right.
You got a quiz today.
Oh wait, no, I'm sorry. This class has a
Oh, that's it. Tell me about
this class and quiz. I mean, one question.
when we have time for retakes though on that quiz that we took.
Yeah. That's why I didn't try to squeeze it in for the last quarter, for second quarter, because there would have been no way I could have gotten it graded and allowed retakes. And I would have not have gotten well on that one. So I have a feeling that's going to be a bad quiz. It always is. It's just a lot of stuff to memorize. I saw it. Oh yeah.
Oh, wait.
Write down.
No.
Are we talking about like the what number range?
Yeah. Out of, I think your class is 464 kids now. It goes up and down because some kids like drop, some kids go up. Wait, what did you say? I saw a different number. Oh Lord. Look it up again. Might have changed. It changes every time a teacher finalizes their semester grade. So when did you look up? I looked up. Oh yeah. So it's gone. But again, your semester grade is what changes this. So right now, teachers are putting in final semester grades. So. Right?
What I get?
So you guys that are ninth graders, you now officially have a GPA.
How much?
Better not be. That's work.
Yeah, that's what I get.
Just alone passing if you got, well, I'm sorry, not passing, but if you got a C on the midterm, you passed the class. And I'm pretty sure you got a C, right? At least. You only had to have a 40% to get a C.
I don't think my GPA that much. At least I still have 4 more rounds yet. I'll take it.
Yeah, it can.
That's why I'm just stupid.
And the farther in, like the more credits you have, the less your GPA changes. That's why you gotta get off to the start. It's hard to get it to go way up, or
GPA, I learned that.
were you at the game the other night, Everett? Gibbs? When we played Gibbs? I think we played him Tuesday night. You there? Gibbs, you go. Yeah, when we played Gibbs Tuesday night.
2, and then he was out of there.
You go?
No,
No.
not me having things.
Yeah, we did not do it. No, I think they have one. I don't know. Maybe they do. I don't know. I know they have one tomorrow. That's what somebody said. Tomorrow.
I thought that was shit was so. Bro, they talking about some fish flying? No, bitch, they're hovering.
Fish. Why? What are we doing today? Break the left up today. I guess we just. Whoa. Whoa.
Let me have this picture. What is this?
What do you think it is?
It's
What is it? What do you think I need that?
Oh, it's stuff about the internet.
Not exactly, not the class.
Only the 4. What else is in class? It's just tell your stuff.
And here's the funniest part of it. I made it up last period before the period, or like while they were doing bell work. And I held it like for the first 20 to 30 minutes of class. I held it. But guess what I forgot to do?
Press record.
Yeah, of course. I'm sitting here holding the sign that says record. Actually, that was second period. Last period, I did record. Second period, I made it up. Totally forgot to actually start the recording. Oh, I'm still recording right now.
Where is my backpack?
Oh my goodness, it's like kindergarten.
Where is my? Why are you taking my bag? I don't
Good
think I-
Lord, it's like kindergarten. Wow. Holy cow. Hands off pocket. Hands off. I know. I wish they would just start dating. I wish somebody would just date somebody, so all that would go away.
Where is my backpack?
Um.
Oh,
What's today?
Thursday.
Oh yeah, you got bell work. What am I thinking? Hold on, you got bell work. I get this class confused. There, that's your bell work. Oh wait, hold on. Maybe we'll switch it up for this class. Yeah, let's switch it. Let's do the new stuff today. Yeah, let's do that for this class. So scratch that. Don't worry about your bell work. Because that bell work is the 3 potential exit ticket questions. So it'd be better to save that and do your bell work tomorrow, right on the same day you're going to do the exit ticket. So let's switch that. All right. So we'll wrap up the other stuff and then we'll do bell work tomorrow. All right. So with that in mind,
Give it back to her.
yeah, let's seriously let's
Stop.
stop being kindergarten kid. Like,
Really?
and that is not what you expect to deal with when you're teaching new kids. I do. Not in every class, only in one class do I deal with that. Oh, you figured I ought to go. You right?
Yeah.
Boy,
He's not here.
so how am I going to break this up? All right, here, I'm just going to show you what's going to be on the big quiz. So again, we're doing it in a different order. Let's talk about the big quiz on Wednesday for you guys. So you need to know how to do those. So I've assigned, write this down if you didn't write this down. This is the big quiz in purple. So write that down. That's your part of your big quiz. We're going to do some new stuff today that will also be on big quiz. And we'll wrap the new stuff up the day of the quiz. So some of the stuff we do the day of the quiz will be on the quiz. But again, you get replays. It's actually got cold stuff. His room, have you ever been in his room? His room was felt like it was 90 degrees. Oh my goodness.
You
gotta sit down. I'll just be standing up here because they'll stare at you.
Really?
Yes. Yeah, because your sister was in here doing it yesterday in 7th period. And like I'd look up and they're just all staring over here at whatever she was doing. She was trying to find something in my cabinet, food or something. All right, see ya. So again, you're writing what's in purple. Those either were tuned out. That's part of your big quiz. Some of it we've gone over, some of it we'll go over today. And then we'll go over some new stuff. We'll start lesson 7-2 today, which is also going to be, at least part of it will be on your quiz as well. On Wednesday for you. Uh-oh. All right, so you should have all that written down by now. It's recorded. If not, I recorded last period. Now I gotta edit it down because I forgot to stop it. All right, so let's go to the problems that are written there, and then I'll go back and forth to do the lesson. All right, so that's 1 through 4. We've pretty much covered those. Concept is you're solving for interior angles. Well, you're solving for X, but you're using the interior angle concept. I would say this is the best process. Circle what's in every angle, because that is the measure of the angle. We can figure out the number that those have to add up to by doing what? There's three ways. So we can just use the formula way, which is just something you could memorize right before the quiz. May not last you all the way through until the EOC. So you might wouldn't hurt to know the other stuff. So that would be the formula. What does that solve for? What's that formula solve for? What in the world is it? The total number of degrees. So once you solve for the total number of degrees, you just write what's in every circle and set it equal to that total. I'm not gonna. So all of the angles added together have to equal the total. That makes sense, right? All the angles added have to be the total degrees. So that's how you do 1 through 4. You just have to know how to solve for the total. We can do it using the formula. We said we could draw in triangles, put a point on one of the vertexes, and then draw in lines. That's the other way. That's basically the same thing as the formula way, because the n subtract 2 part of the formula is just figuring out mathematically how many triangles instead of drawing how many triangles. And then the last piece is you multiply by 180 because we have 3 triangles there. What was the other way we could do it? And again, this is really the best way to do probably your entire quiz. Are you saying? Table. I couldn't, but I was expecting the word chart. I was like, what is she saying? So the other way would be just, and again, this would work great even on the EOC if you can just kind of recall the concept. Oh. You could create a table that has practically everything you're going to need for the entire quiz. Well, the entire first lesson we did. You could say, well, I know if it has 3 sides, which is what figure? A triangle, right? What's the sum of the interior angles of a triangle? We just know that. So you could say, well, if it has 3 sides, I know the interior is 180. You could even add a last column and say, well, if it's a regular triangle, which is what kind of triangle? The name of that triangle.
What?
A regular triangle is also has another name. It's equilateral. Remember, all the sides are the same length, all the angles are the same measure. That was equilateral. So if I know it's an equilateral triangle, a regular polygon, I would just divide 180 by 3, and that tells me what each angle is. Because all 3 angles have to be the same if it's a regular polygon, and they have to add up to that number. So that would be 60 plus 60 plus 60. Try that again. 60 plus 60 plus 60 adds up to 180, and they're all the same measure. So if it's a 4-sided figure, again, you kind of just know what a 4-sided figure, think of a rectangle. If all 4-sided figures are the same, so if you can think of one that you know, like a rectangle, well, I know it's 90, 90, 90, and 90, so that's 360. Well, if I then wanted to know if it's so what is a regular rectangle, a regular polygon that is a 4-sided figure?
What?
A regular polygon, what's the definition of regular polygon?
Oh.
Same length sides, same measure of angle. So what is a 4-sided figure that is a regular polygon? Square. Same, all the sides are the same length, all the angles are 90. So that would be square. So for a square, I would say, well, I know the total is 360. I know every angle has to be the same. Well, there's 4 angles. So that would be 90 plus 90 plus 90 plus 90. So each individual angle is 90. That's what this column is. What is one angle of a regular 3-sided figure, or a regular 4-sided figure, or a regular 5-sided figure? That's what this last column is. So if you added all those in and you just extended it way out, like even beyond what we did, yeah, I think we did this the other day, if not. If you extended it way out, I mean, all you're doing, what are we doing in the middle column every time? We add a side. So if we go to the next one, what are we doing? Just adding 180, right? Anytime you add a side, you're adding another 180 degrees. And then all we're doing over here is just dividing these two, saying that divided by that. you could create that chart probably down to 20 or 30 sides in like 2 minutes. And it would give you literally every answer you would have from the lesson in the first chapter. Because if I tell you, I mean, the only thing you would do is, you would have to solve for x. Like, it would give you all the internal degrees you needed for any side. So again, going back to that problem, you could just look at the chart. Okay, it's got 4 sides. What's the total internal degrees? 360. It's got 5 sides. What's the total internal degrees? Go to your chart, 540. I mean, and then if it was a more complex figure with 8 sides, you go down to 8 sides and see what the total is. And if it said it was a regular polygon and you had to do something like what we did for the bell work the other day, I think this shape, I believe, actually it might have been 8 sides, but let's say I give you that and I say that's a regular polygon, solve for x. Well, you could just go down your chart, find 6 sides, and go all the way to the last column, and it tells you what the degrees in 1 degree are. You wouldn't even have to solve it out. You wouldn't even have to set anything up. But again, you have to set that up on your own on the quiz. I'm not going to have notes. I wouldn't try. You can memorize how to set it up, like just keep adding 180 and then just divide the 2 out. I would do that if I were you. And then I'm fine with that as long as you write the chart on the back of the quiz or something. I see you created that. Then you really don't have to show much work at all. Let's see. What else do we need to go over? Oh, that's the 3 ways. So the formula way, drawing the triangles in, or creating a chart. They're the ways you can find the internal degrees of a polygon, or one individual angle if it's a regular polygon. Or the more difficult regular polygon question is this. What if they don't tell us how many sides? So again, it's a regular polygon. There's a formula you can use that says, well, we can take the number of sides. I'm sorry, not that. That's what we're solving for, is the number of sides. Because again, they gave us the measure of the angle, right? That's the measure of one angle for a regular polygon. So we would take 360, divide that by 180, subtract the measure of one angle. So in this case, 144. If you solve that out, you get, I think for that one, I think it's 10. So again, you can try to memorize that before the quiz. But now, as you probably keep hearing me saying memorize, this would be a lot of memorizing. Or if you had just created the chart at the beginning of the quiz. Don't know where my other arrow. Here. Yeah, I don't know what happened. Huh, that is really weird. So if you had just created the chart at the beginning of the quiz, you could just look at your chart and say, okay, well, if one angle is, what is going on with my, that's so weird. If one angle is 144 degrees, and in my chart, I created what one angle would be, I just find it in my chart, and I go over there and see how many sides. Again, you might have to extend it past 144, because if you'll notice some of the practice problems in 9 through, I think it's 9 through 14, maybe? Yeah. Some of them go past 140. Yeah, that one goes to 156. That one goes to 160. That one goes to 150. So you'll have to make one farther down than where I ended, where we did before, if we did it in this class. But I don't care if you do that as long as you create it on the quiz. Like, you can't just write a number down on the problem. You got to show me the chart somewhere on the back of a page or something. All right, so here's the relatively new part. We had kind of done some stuff with regular polygons, although that was a little different. God, I don't know what's wrong with my board. I'll have to restart it. So which part of the lesson is it? Turn to page, it's on page 8, I believe, if you want to get your book pages out, because I don't know where it is in here. I don't think that's it. Nope, that's not it. Is it? No, that's not it. That it? Yeah, there we go. All right, so So I think I might have just told you this. We didn't really do a lot with it. So in a polygon, we will typically see it like this. You know, we'll see a triangle, we'll see some kind of a four-sided shape, we might see a five-sided shape. It doesn't matter if it's regular or anything for this particular lesson. If we just see it like that, the problem is going to be about the internal angles. Right? There's nothing else. All we have are angles inside. There's nothing outside. If they're doing this weird thing here where they're drawing a bunch of arrows extending outsides, that's not a hint. I mean, it is about. It's about exterior angles, or maybe both, maybe interior and exterior, but it's definitely about exterior. They wouldn't extend the sides out if it's not going to be about the exterior angles. There's no need to do that. So, with that in mind, the concept that they gave us, so if I extended them out here, they'd look, something like this. It always has to go around in the same direction, like counterclockwise or clockwise. Don't think of it as left, right, up, down. So for these, the arrows are always going that way, right? So it's like going around in a circle, sort of, if you think of where those arrows are coming from. So it's like going around this way. So with that in mind, if we have all the exterior angles of a polygon, and if there's 6 interior, there are 6 exterior. Go over that a little bit more in a minute. All of the angles that are exterior angles have to add up to 360. It never changes. It's not like the interior angles where it depends on how many sides. I don't care if it's a triangle. I don't care if it's a polygon with 37 sides. The exterior angles will always add up to 360. Now, for my quiz, especially if you look it over real quick beforehand, like before, even right before, you can memorize it. That's not going to be difficult to memorize. I don't think that'll be difficult. Exterior angles outside the triangle adds up to 360. On the EOC, you're probably not going to. So there's a way to kind of back into that number. Like, let's say you see a problem on the EOC and it's about outside angles, and you're like, oh crap, was it 180? Was it 90? Was it 360? 540? I don't remember. What could you do? You guys being super smart. What would you do? Which strategy? That's not guessing. It's not just giving up and not guessing. There's no other strategy besides giving up and guessing. Well, those are good strategies. Those are great strategies. And this works in a lot of geometry. Okay. So the what? And what do you mean finding? I haven't given you any. Okay. But how would I? Like let's say they're not giving you a measure of the interior angle. How are you going to find the solve for the exterior? They're not giving you the measure of the interior. Like this figure doesn't have interior. How are you going to solve for the exterior to know what they total? Say what? Well, yeah, don't know. I'm saying you forget. You forget the number because again, remember the EOC is in 3 months. You're not going to remember every formula we ever do. Happy you didn't remember the next quiz. I try to teach you an understanding method, but that won't stick. So here's the thing that I tell you a lot on a lot of different things. When I say no exceptions, if there's no exceptions, then just pick one case. Pick something you know, and if it's true for that, it's true for everything. There's no exceptions to this. It is always the same number. Always. So pick an easy triangle. That was supposed to be an equilateral triangle. And now let's make it even easier. Let's make it an equilateral triangle. What's true about the angles of an equilateral triangle? And so what are they? So I know for an equilateral triangle, and this will work even if you're not positive that there aren't exceptions. This is better than giving up. Like apply something that you know. Might be wrong, but again, better than just randomly guessing and giving up. Especially on my quiz when you get partial credit for some stuff. So if I know that all of the interior is 60, now we can do what you were saying. And again, my shape, it doesn't have to be a triangle. Now, I'm going to do it with a shape that has 6 sides, and we can still do it. I'll show you that in a second too, since that's what that particular problem has, and they didn't give us anything inside. If it is true for a triangle, for this triangle, it'll be true for every triangle. What's the exterior angle, each individual? Yeah, we would do this little thing, right? Semicircle, semicircle, semicircle. So if that's the case, what's the semicircle thing mean? Andrew. So real quick, here's the deal I've made with other classes. I'll make it with you. Some of you don't like being called on, but I'm going to have to call on people more. I can't let people sit there and not do anything and not get it when grades are horrendous. Can't do that. So I'm going to start calling on you more. You're going to be quiet. So those of you that fall into that boat, and there's a lot of them in this room, if you do the problem, you can't just write a number down. You can do the first step and then the answer, like you don't have to write a ton of stuff. You don't have to recopy the whole problem onto another paper. But if you want to recopy, it's kind of like the question thing that I told you to do if you wanted to write a question and crumple it up and throw it. If you do that, put your name on it, crumple it up, throw it up here, and I can check that you've done the problem, even if it's wrong. I mean, then I might come back and say, hey, you need to correct this or whatever. Then I don't have to call it. So that will get you out of being called on if you don't like being called on in front of your peers. A lot of you don't care about being called on, so you don't have to do that. But just know I'm going to have to start calling people more. All right. So again, if all of those semicircles add up to what? 180, then that means every single external angle has to be 120. And if I have 3 of them, then it adds up to 360. And you could do that for whatever shape. Just if it's not a perfect regular polygon, use a regular polygon. There's nothing like, if it works for one polygon, it's going to work for all of them. So use a regular one where you can solve for the individual angles. So if we had a regular polygon, that's not a very good picture of one, but what would and again, assume that's regular, and then we have all the sides extended. What would every individual angle be? You guys should be able to figure that out. I want you to figure that out. So an individual angle of a regular polygon is what? We've done that before. I think we did an octagon. Well, no, I need a number. I want you to all to figure it out. Don't say answers out. Try to figure it out. I mean, if you did a chart, you would know also. If you already had your chart, and I need to look at it. But that would be the third column that you would have figured out was what one angle of a regular one is. But I want you to try to figure it out first, since I don't think most of you did the chart. I heard somebody that you'd say. So again, the formula we learned you can use to get the total. And it's the total interior degrees divided by, technically it's the number of angles, but I think the formula said number of sides. Find the total degrees for a hexagon is 6 sides. Find the total degrees for a regular hexagon and then just divide it by the number of angles. Give it a minute. I'm going to give you a hint. Not a hint, but we just kind of get it started. If you are visual, I don't want to do that.
The triangles, number of triangles.
All right. So again, I don't care how you do it on the quiz, but somehow you need to come up with the total degrees, which is what? six-sided figure. 720, right?
Yeah.
Because we have four triangles, right? You didn't subtract the two, I think. Be careful. So four triangles, 4 times the 180 gives me a total. I guess I'll do it up here. So the total of the interior is 720. But if I know it's regular, then that means every single angle has to be x. So x plus x plus x plus x plus x plus x has to equal 720. Well, that's the same thing as saying 6 times x, and then I just divide by 6. So that is one individual interior angle, but we know that the exterior angle's in the interior, so somehow I got to get rid. Here, let me try this. I got rid of some of it. I'll fix it. So if I know that an interior angle is 120, and I know, and I want to solve for an exterior, because all the exterior will wind up being the same, because all the interior is the same. What's an exterior? What is it? So an exterior, all exterior 60, right? How many exterior angles do I have? Yeah, same number as the interior. So you always have one interior paired with one exterior. So 6 times 60 gives me 360, also in the exterior. So you can back into that number. It's not even super, super difficult. You might have to do a little guessing because, not everything, some rules do have exceptions, like it only works some of the time, not this one. So if you can figure it out for the regular version of that same polygon, it'll work for every version of that polygon. Total will always be 360, or the total of the interiors will all be the same, whether it's regular or not. Again, just don't give up. Like a lot of you give up too soon. Try to do something you think might make sense. And a lot of you need to not give up because you still need to pass your algebra requirement. And that's part of it, is not giving up. Just trying to make the best educated guess you can make. All right. So that's the exterior. So that is these problems here. So 15 through 18. Oh, I circled all of that just to remind you, whatever is in the angle is the measure of the angle. Don't freak out because it's not just a number. I don't care if it's x plus 18, what's more, 3x plus 2. Those are the measures of the angle. Those measures, those angles, have to add up to whatever the total is. And then you just have to figure out how many total degrees and add all those up and set it equal to the total. And then solve for x. That is a big quiz question, like your Wednesday quiz. I mean, it could be something like that about external angles. Not for the exit ticket, but for the big quiz. Again, if it's a problem I've assigned, then it's potentially on the or you're I don't know who is supposed to. Anybody have? Are you fine with that? All right, so now go ahead. I think, really quickly, actually, there was one more thing I was going to show you. If you get something like that on the EOC, we didn't talk a lot about the names of figures. Just try to figure out, I mean, we already wrote it, but pentagon, the prefix pent means 5. So you don't just know that. I mean, there are other things, like there's literally a building called the Pentagon. That's a political building that is a 5-sided building. There's also an athletic event from a long, long time ago that is called. There's an athletic event that was called the pentathlon that had 5 events in it. I can't think of it. Can you think of any other good example of that? And I can't think of one. For octagon, everybody better know octagon, because what do you think of when you hear oct? OCT, octopus, right? Has 8 tentacles. What about nonagon? How can you remember that's 9? It's kind of like 9, right? 9. 15agon just means it's got 15 sides. Once they get over 12, I don't think they name them, although somebody said they still did. Hexagon's kind of, I don't know how you remember a hex is 6. I can't think of anything that's what that. Other accidents. So let's see. If you happen to get that, once you know how many sides, it's the same thing. We know all the exterior angles have to add up to what? So then you're just dividing 360 by the number of sides. You just may apparently have to memorize some of that. So I'm not giving you that on my quiz, but that's more of a EOC district. Oh, we will probably take the module 7 common assessment that the district gives us. So they could put something like that on there maybe. All right, now let's move forward though to the next lesson. So turn to page 13. Anybody not tear the page down? I think we're good in here.
Boxes up there.
They are, yeah. I was thinking about sending an email if anybody wanted them. They are good. They are good boxes, yeah.
We're doing that shredding. Do you have any paper that needs shredding?
I usually throw my own.
Oh my God.
All right, so we are moving into a new topic, parallelogram. If you notice, this is kind of weird why they did that. I don't really understand why in the world the lesson was the lesson that we did. Because did anybody notice the name of this module? Like the very first time we tore pages out, what the name of the whole module was, not just like the one individual lesson that we just did, because that was angles and polygons. The whole module was actually called quadrilateral. But for some reason, they did the first lesson wasn't just about quadrilateral. We did all kind of sided figures. What's quadrilateral mean? Yeah, 4, right? So the whole module is supposedly about 4-sided figures, but yet the first lesson we had all kind of sides to figure. So I don't know why they put that lesson in this. It shouldn't have been, in my opinion. They should have done that probably last semester. But regardless, we are now in only 4-sided figures. A parallelogram has to have only 4 sides. Now, that doesn't mean there aren't other figures where the opposite sides are parallel, because there are. They're just not technically called parallelograms. So again, has to have 4 sides. Make sure you understand that. Because the stuff that we're going to talk about is only going to be true in 4-sided figures. So what do you think the other piece is besides 4 sides? Based on the name, what do you think is going to be part of it? Okay, here's where I start calling people. Caden, what do you think is going to be involved based on the names? Yeah. Parallelogram. Where do you think that came from? Parallel lines, right? Oh, I guess our whole class stuff. What's going on in the hall? There's like 32 of it. Her? Why is she in our hall?
Oh, it's the buses here from the immigrants. They're coming.
Oh, okay. She went out to do it. I got you. All right. So Pinsker out there. All right. So in a parallelogram, there are some things that are always, always, always true. That's what a theorem is. Something that has been proven to be true. Now, again, you can memorize all the things we go over today. Not sure how long that'll last if you memorize it, or if you'll be able to memorize it without confusing them. So I'm going to try to explain why it's all true so that maybe you have a better understanding of it instead of just trying to memorize like 7 or 8 different new things. But with that in mind, all these theorems, and then there's more. I think there's more on another page somewhere. Yeah, more. So 8. So you can memorize all 8 of them if you want. Or if you get an understanding of it, I think you'll be in much better shape. I'll do that in a second. So again, dealing with parallelograms, we said that means that's going to be true. Both sides of that figure are parallel. So we have two parallel lines going kind of up and down that are parallel to each other. And then we have two parallel lines kind of going left and right that are parallel to each other. Anybody remember when we did some other stuff with parallel lines? This whole figure, this whole lesson is all based on one concept we already learned. When did we do something else with parallel lines? Yeah, let me do. All right. There was another time when we did quite a bit with parallel lines and this other thing that had a special name. Special. So hopefully you remember this picture. That's what this whole lesson is about. Everything we do is really just that. It's just we've eliminated part of it. So we've kind of like said, well, let's erase this part over here. And let's erase this part down here and up here. And then let's kind of attach that same thing onto the other side. And then boom, the middle is basically a parallel. Or if I did two parallel lines there and two parallel lines there, the lesson is basically just about, oh, let me do that. The lesson is just about this part of that parallelogram that's inside that picture. But everything is based on that same concept. So it's really not that bad if you understand that, if you remember that concept. Because what kind of stuff did we learn? Oh, I like doing it this way. I wish I would have thought of this before. Hold that thought. Let's just draw that other figure up there. All right, so again, our parallelogram up there is this part of this figure. So again, that's where that figure up there. We just got to cut it out and put it up there. What did we say is true about this? Why is it? What's true about the angles in that figure? There's one specific thing that made that a super easy figure to deal with. Yeah, there were a bunch of angles that were congruent to each other. Like four of the angles were the same, and then the other four were the same as each other. So we said if we knew, I'll do it down here, if we knew this angle was 60, then we can start filling in a whole bunch of angles just right there in that spot, right? Because what's true about the angle next to it? Got to add up to 180, right? Like we've done a lot of this stuff over and over again. None of this is new, really. It's new theorems you can try to memorize if you want to add more stuff to memorize, but you just understand this is all the same stuff we did before. Not really that new at all. What did we learn about? Remember vertical angles that are across from each other? What did we learn about vertical angles across from each other? They're congruent, right? So I could have said, first, I could have done that. But really, I could have also said, well, wait a minute, that's actually also a semicircle. So I could have solved for 60 that way. Now, what's the missing one up there? Yeah, I could say, well, then 120 has to be across. I could say this one has to add up to 180 with the 60s. However I do it, I get to that. Then what was one of the, and I think it was you, Abby, that said it, what was one of the definitions, oh no, I'm sorry, it was Sarah. What was a definition we learned to kind of jump from here down to here, or from here over to there in this case? There were three definitions we learned. We proved them too, I think. What'd you say? You said one started with C. No, did you say corresponding? You said corresponding. Somebody said, I heard somebody say it, yeah. We learned that there were 3 definitions for particular angles that allowed us to jump to the next spot. We learned alternate, thank you, alternate interior, alternate exterior, and corresponding. And that allows us to say, okay, well, if I know this is 60 here, this one is also 60. That's corresponding. Or I could have said, if this is 60, that's 60. That's alternate interior. And you really only need to know one, because as soon as you put one number over here, now you can do the same thing we did over there, solve for all of them, and now we just keep repeating them. Well, if I know this is 60, I can say this is 60, alternate exterior. Or I could have said, if this is 60, that's 60. That's corresponding again. You only need to know one of those 3 definitions. And then once you're able to put one number down here, if I know that's 60, those are 120 because they have to add up to 180. Again, same thing. If I know that's 120, corresponding angle says that's 120. Well, then that has to be 120. Well, and that has to be 60. That has to be 60. So there's really only one thing you need to memorize, and that is either alternate interior, alternate exterior, or corresponding. And from there, you use the same stuff that we've done over and over and over again, vertical angles. So with that in mind, what happens, what had happened was, that's congruent. That's congruent. Like look down where we solve for stuff. Those are congruent angles. What's true about the 2 angles if they're not congruent? Look at the 2 numbers. Well, the 2 different, like in the picture down there, if they're not congruent, then what's true? Then they have to add up to 180. Same thing is true here. If they're not congruent, so these are not congruent, right? One has 1 tick mark, one has 2. What's true about them? You just said it. Yeah, if they're not congruent, they have to add up to 180. So those add up to 180. These add up to 180. These add up to 180. So I think in the book, under the theorem, it calls them consecutive angles. So consecutive, so opposite, so again, these are the first 2 theorems on page 13. Opposite angles are congruent. Well, we just proved that out. Opposite angles are congruent. Consecutive angles, meaning sort of next to each other, like in a row next to each other, or whatever you want to call it. Consecutive angles add up to 180. That's your first 2 theorems. Actually, I don't know if it's your first. It's 2 of those first 4. The other theorem, and I'm going to do a very quick version of that. The other theorem, and now I'm going to kind of get rid of everything except for the original picture. The opposite sides are also. So that side, and again, it comes from the fact that all the angles are congruent, or a lot of the angles are congruent. And for example, if I drew a line right there, if I know that these angles are congruent here, I also know these angles are congruent, right? Because that's back to alternate exterior. Again, it all goes back to the 2 parallel lines cut by a transversal. I also know these are congruent. Again, that's alternate exterior. Alternate interior, I'm sorry, not exterior. I wind up having a bunch of congruent triangles, no matter where I draw lines. If I draw a line through there, I got a bunch of congruent angles, a bunch of congruent lines. A bunch of congruent angles, a bunch of congruent lines. So ultimately, we just have a bunch of congruent triangles. We can prove that this triangle here is the same triangle as that triangle there. We can prove this triangle here is the same as that triangle there. So that's why you wind up having all these little mini things true. So here's the ultimate thing that all those theorems are saying. If we, what are the, I gotta redo that. That's even bad for me. So if I draw in, what do you think those are called, those lines? Are they straight up and down? Are they straight left and right? So what are they called? Diagonal. That's literally the name of them. They're called diagonals. A diagonal is a line from one vertex across to the other vertex of a quadrilateral. It's really only for quadrilaterals. So what's true about this figure as far as congruence goes, because we're ultimately just going to wind up with a bunch of congruent triangles, all that stuff is true. And then we already talked about a bunch of angles being congruent. This angle would be congruent to that. That will be congruent to that. Obviously, vertical angles are congruent. Like, you just have a bunch of congruent triangles. So all you got to do is figure out which parts of those congruent triangles are the ones that I need to match up. So yeah, in the problems, you'll see everything is based on knowing which pieces of the triangle. It's based on knowing which pieces of the triangle are congruent. And if you know they're congruent, you're just going to set them equal to each other if it's the sides. If it's the angles, you might either set them equal to each other, or you could potentially add them together and set them equal to 180, just like we did in that other figure. So that's where we'll stop. I didn't assign any problems at all yet for that.